Here we go with the second set of video notes in the Chemistry of Life series, this one on organic molecules.
Okay, so moving on from water, talk a little bit about the chemical compounds of life. In fact, for this one, if you don't want to write this whole thing for your sidebar, you could just write the elements of life would be fine. So the four main elements that make up most living critters are carbon, nitrogen, oxygen, and hydrogen. So we look over here, we got carbon, oxygen, hydrogen, nitrogen. So most of these guys right there. Of course, hydrogen because it's part of H2O. So these guys, main elements. Also, you have a little bit of sulfur and phosphorus. So a little bit of sulfur and a little bit of phosphorus. So most of our stuff coming from right there. And these elements all combine together to form some unique molecules. All right? These molecules that are made up of carbon, hydrogen, oxygen, nitrogen, they can fall in a couple different categories. One, they could be what's considered inorganic molecules. So these are mostly molecules that do not contain any carbon. Right? An example of things that do not contain carbon, water, right? H2O. Table salt is NaCl. Most different rocks like granite, they don't really contain any carbon. Sand, kind of like broken down rocks. These are all things that are inorganic. Right? Organic molecules, on the other hand, are things that are made out of carbon. You could also think of them as things that are living. So they either are made out of carbon, or they are made out of carbon, they either are living or they used to be living. So obviously plants and animals would fall under organic life forms, right? They're made out of carbon. Also things like coal, right? Even though it's like a rock, it's still made from living things, fossils, also proteins, fats, things like that are all considered organic molecules. The one exception to this, or at least a major exception to this, is carbon dioxide, CO2. Not really considered anything that's living or was living, just another compound. Don't get this confused with organic that you see like in the grocery store and things that have pesticides or don't have pesticides, things like that. They're kind of trying to borrow from that, thinking of nature or from nature, but a little bit different in the scientific aspect. What is it about carbon that's so great? Well, why is carbon so essential for organic molecules? Well, mostly it's, again, comes down to chemistry. It's got 4 electrons in its outer shell. So that means it can bind up with up to 4 other atoms and can form lots and lots of different shapes. So it can, the simple tetrahedral shape of methane, you can form these like chains. You could form chains with double bonds that are like kinked, so they bend back and forth. This crazy isohectane, they can form rings. Lots and lots and lots of different shapes, and these different shapes give the molecules different properties. So one of the ways that we get all these different shapes is through a process called polymerization. Right? This is when you take a single unit of something. We call this a monomer, right? Or a single molecule, a simple molecule, just the base unit of that molecule. That's a monomer, and poly means many. So polymerization is when we just join lots of those things together. Right? So polymerization, making of polymers, is when you have the small compounds or the monomers are joined together to form very large ones called polymers to help you make these very complex molecules like what you saw on the last slide and like many of the things that we're about to talk about. Some things just to keep in mind, some helpful prefixes for you. Mono equals 1, di equals 2, tri equals 3, poly equals many, macro equals large. So if we had a monomer is a single unit, a dimer is 2, trimer is 3, poly is many, and a macro just means that like a macro molecule would be a big molecule. So the macromolecules of life that we're going to talk about are carbohydrates, lipids, proteins, and nucleic acids. And these are the major things that the carbon is arranged in these different to make different molecules of carbohydrates, lipids, proteins, nucleic acids, and they all have very different jobs, very specific jobs within your body, and that's what we're going to be talking about from this point forward.